We are going to create a template for our HMI application. A well-defined template plays a very important role in reducing the complexity of the machine. So with all this talks about templates, you might wonder, what does a template actually look like? A template typically consists of three main areas. The screen navigation area is used to navigate through the different main screens of the application. The information area, or the information bar, because it's typically shaped as a bar, displays valuable information that you would like to have displayed on every screen of your application, like for example the date and time, the actual recipe running on the line, or the current user that is logged on to the system. The final area of the template is the actual screen content area. This content is screen dependent, and all of this will get much more clear in the next lectures. Important here when designing the layout of your template is the shape of your screen-specific content area. When you are thinking about your screen layout, try to keep the aspect ratio of your main content area about the same as the aspect ratio of the panel. You don't want to stretch out your main content area too much horizontally or vertically. In this picture right here, our main content area is a rectangle with about the same aspect ratio as the panel itself. Now I'll show you an example of a layout that is less pleasing on the eyes. On this picture right here, you can see that the main content area is wide but not very high. It will make the information that you will put on your main content area feel cramped in there. Now before we get started with creating a template, I would just like to mention something about selecting main colors for your application. My advice to you is to select a maximum of 2 to 3 main colors for your application. Don't go nuts with using different colors everywhere in your application. Modern applications only use a couple of main colors throughout all the screens of the application. You will need at least one light color and one dark color to create contrast. Contrast, for example between a text and its background, is very important because it makes the HMI calm and easy on the eyes. A third color can be chosen for some accents and variation. Screen templates are situated in the tree structure under Screen Management. Under Screen Management, we open the Templates group, and you can see here that TIA Portal has automatically created a default template called Template 1. Let's rename this first to Template, since we are only going to create one template for our HMI application. So we click on the name, we press F2, and we rename. Now if we open this template, it's obviously still empty. There are no objects, elements, or controls here yet, and it's up to us now to go to work on this empty canvas. We're going to add 3 layers in total to our template. At the bottom layer, we are going to add our background graphic. The middle layer will contain the main graphics, and in the top layer we will have our text. This will all get more clear in a second. We start with our bottom layer, the background of our template. Throughout the course, I will be using custom graphics which I have created especially for this course. In order to achieve a modern look for my applications, I always create most of my graphics myself. You can of course just use the standard colored squares, rectangles, etc. that TIA provides, but if you really want your application to stand out, create your own graphics. At the end of this course, there is a bonus lecture introducing you to the free software that I use for creating great looking vector graphics for my own HMI applications. So don't forget to check that out. Now if you look at the resource section of this lecture, you can see that I have attached a zip file called graphics.zip containing all the custom graphics created for this course. We will start now by adding these graphics to our HMI application. All graphics for application will be stored in the tree structure under Languages and Resources. Now it's worth noticing here that the Languages and Resources group is a group for the whole project Refill HMI work, not just for the HMI application HMI Refill. Let's open our project graphics and start adding our custom graphics. I haven't found a way yet to import custom graphics in bulk. If any of you out there has a better way of importing a group of graphics in one action, please share it with us. To add a graphic, we double-click on Add New and we select the first graphic in the list. Now we repeat this for all the other graphics. We're going to speed up a little bit here to save time and to make sure you guys don't get bored. There, all done. If you have a quick look here at the names of the graphics, you can see that I've used a system for assigning names to my graphics. I start the name with the function of the graphic, followed by the definition of the graphic. So for example, I have lots of graphics for buttons, so each graphic starts with the abbreviation BTN for button, followed by the description for that button. This system of naming the graphics makes the process of adding graphics later on very intuitive. You'll see. So now that we have our graphics added to our library, let's go and add the background to our template. To add a background, we are going to use our toolbox here on the right side of the screen. The toolbox contains three important sections: basic objects like lines, rectangles, text, and graphic views, elements like buttons, I/O fields, bars, and sliders, and controls like an alarm view, a recipe view, or a user administration view. To add a background graphic, we simply drag and drop the graphic view object onto our template. There we go. We have added a graphic view to our template. Let's open its properties by double-clicking on the object. Now here on the general, we are going to select the background graphic that we would like to use. So we click on Background Template, and we've got a very small square with a background on our template. Well, it's a great start, but obviously not the final result. We still need to scale and position our background, and we do this under Layout. Here we can change the position and the size of our graphic view. We could manually adjust the size here, but since I have made all my custom graphics in the correct size already, the easier way to resize our background is by using the Fit to Size here on the right side. We are going to adjust the object size to the size of our graphic. There we go. Now our background has a size of 800 x 480 pixels, which is the original size of my custom graphic. Now we just need to position it correctly, and we do this by entering 0 for X and 0 for Y. And there we go. Our background graphic is sized and positioned correctly. So that's it for our bottom layer. Now that we've mentioned layers a couple times, let me show you how to assign a layer to an object. In the properties of each object, there is a property tab called Miscellaneous. In here you can assign a layer to your object. There are 32 layers to choose from, starting with layer 0, which is the lowest layer, to layer 31, which is the highest layer. To manage your different layers, you select Layout from the vertical menu bar on the right side of the screen. Here you can see the different layers and the objects which belong to them. At the moment we have only created one object, our background, and you can see that it is situated under layer 0, the bottom layer. You can drag objects from one layer to another. For example, let's drag our background from layer 0 to layer 1. Now what I personally really like here is that you can rename the layers. These names are individual for each screen, so you can set up different layer names for each of your screens. Let's add, for example, background to the layer 1 name, graphics to the layer 2 name, and text to the layer 3 name. By giving each of these layers a distinctive name, we have made it very easy to recognize layers and to add objects to the correct layer. Finally, there is the option to change the visibility of each layer in the offline project, except for layer 0. These visibility properties are only there as a tool to help you create applications. In a runtime application, the layers of your application will always be visible. So if we click on the visibility property of layer 1, you can see that the objects under layer 1, which is only our background, become invisible. There will be more examples later on in the course on how to assign and use layers to your advantage. Now let's continue with the design of our template. On top of our background, we are going to add the main template graphics. To start with, I am not going to go into detail. I am just going to allocate some space for them so we get an overview of the main layout. We are going to create 4 rectangles here. One rectangle to visualize our top bar, one rectangle to visualize our screen navigation area, one rectangle for our start-stop buttons, and the last rectangle for our main screen content area. To add a rectangle, we drag and drop the rectangle object from the toolbox. Since new objects automatically are assigned to layer 0 and our background is assigned to layer 1 at the moment, our new object is created underneath of our background. So let's change this. First we make the background invisible here in our layout options. Now we select the rectangle and under miscellaneous we assign layer 2, our graphics layer, to the rectangle. We make layer 1 visible again, and you can see that the rectangle is on top of the background now. Let's change the properties for this rectangle. Under Appearance, we are removing the border, so 0 for the width. Now we need to assign a color for the background of our rectangle. As you might remember from the previous lecture, we have selected 3 main colors for our application. Light gray and dark blue for contrast, and finally a dark gray color to add some variation. Since we are going to use these colors quite a bit throughout the application, let's add them as custom colors to our color palette. We do this by opening the color palette here and selecting More Colors. Our light gray color has the RGB code 228, 228, 228, so we enter those values for red, green and blue. And then we save this custom color by assigning it to the first color slot here in our user-defined area. Now we add our dark blue color with RGB code 03485 and we assign that to our second user-defined color slot. Finally, we add our dark gray color, RGB code 97, 104 and 125 to the third slot. Great, so now we don't need to remember these RGB codes all the time because we have saved our 3 main colors in the user-defined color slots. Let's exit this color screen and let's assign our custom light gray color to the background. Now that we're done with the color, let's go check out the layout. Under Layout, we change the size to a length of 692 pixels and a height of 38 pixels. Finally, we need to position this rectangle correctly on the screen. To position objects on a screen, TIA Portal gives you 3 options, and these options can be selected under the Layout Management. So let's open that one first. Under the category Grid, you can select the Layout mode. If you select Snap to Lines, objects that you move around on the screen will snap to lines of other objects on the screen. If you select Snap to Grid, the objects that you move will snap to the grid of the screen. Below here there are some extra options for the grid, where you can define the grid size and the visibility of the grid. Finally, you have the option to deactivate snapping by selecting None here. If you select None as the layout mode, your objects will not snap to anything when being moved around. They can be moved around freely with a 1 pixel precision. The easiest way to move our rectangles around is by snapping to the grid. So we select this option here. Now we drag our rectangle to the top left corner of the screen, and because we are snapping to the grid, our rectangle can be placed perfectly without showing any visible spaces to the top or to the left of the rectangle. So this is the basic layout for our top bar. We will build the top bar in detail in a later lecture. For now, we are just allocating a space for it in our template layout. Next up, our screen navigation area. We could just drag and drop another rectangle from the toolbox, but it is much faster to start with a copy from the existing rectangle. This way we can skip most of the setup, which saves us time. So we start by selecting our top bar rectangle here, and we copy it, Ctrl C, followed by Ctrl V. Our screen navigation area will have a width of 104 and a height of 312, and we position it all the way in the top right corner. For our Start-Stop buttons area, we start again by copy-pasting an existing rectangle and changing the layout properties afterwards. We keep the same width as the screen navigation area, and we change the height to 160 pixels. Finally, we move it to the bottom right corner of the screen. Now we are just missing the allocation of our main content area. We start again by copy-pasting an existing rectangle, and now we go and change the properties. For this main area, I would just like to show a thin, elegant frame without a background around the main area. To achieve this, we go to Appearance, we define a border with 4, and we assign our custom light gray color. Finally, we make the background transparent. The only thing missing now is the size and position of our frame. Under Layout, we set the width to 688 pixels and the height to 434 pixels. Since the frame needs to be in a specific position, we are not going to use the Snap to Grid function here. Instead, we are manually assigning the X and Y values, 4 for X and 42 for Y. So that's it for our main area frame. Let's move the Start Stop button area up a couple pixels so it aligns nicely with the bottom of our frame. So far we have added a background and we have visualized the layout of our template using rectangles. In our final step, we are going to add some descriptive text on top of each rectangle to clarify each area of the layout. To add text, we drag and drop a text field from our toolbox. The text will be on top of the rectangle, so we assign layer 3, our text layer, to it. Under General Properties, we change the size to 15 pixels. Under Appearance, we change the color to our main dark blue color. And under Text Format, we change the alignment to horizontal centered. Now we change the text name and we copy-paste the text to the different areas of our template. So this will be the basic layout of our template. In our layout management, you can see that the background is assigned to layer 1, our bottom layer, the rectangles are assigned to layer 2, our middle layer, and the text that we've just added are assigned to layer 3, our top layer. We can toggle now the visibility of each layer to get a feeling for how our template is layered. By using layers here, we have created a logical structure in the design of our template. In this lecture, we're going to add screen navigation to our template. Screen navigation is an important aspect of the template because it allows the user of the application to jump directly to any of the application main screens independent of the screen that he or she is currently on. In our case, we are going to have 4 main screens: a process overview screen, an alarm screen, a recipe screen, and an HMI settings screen. We are going to add screen navigation to our template by following these 4 steps. First, we are going to create 4 graphic lists, 1 for each button. Each graphic list will contain 1 graphic for the inactive state of the button and a second graphic for the active state of the button. In our second step, we are going to create 4 local Boolean tags, 1 for each button. These tags will be used to define which graphic from the graphic list should be displayed for each button. In our third step, we are going to create our 4 main screens. Finally, in our last step, we are going to add and configure the 4 screen buttons on our template. So let's get started with our first step, creating graphic lists. To create a graphic list, we go to our tree structure and we double-click on Text and Graphic Lists. Here at the top, we can choose between text lists and graphic lists. We are going to create graphic lists. We select Add New, and we are calling the graphic list for our Process Overview button, Graphic List, Button, Template, Overview. By using a descriptive name like this one, it's clear that this is a graphic list for a template button, in this case for the process overview. Now we add our graphics. We do this under Graphic List Entries. We are going to add two graphics, one for our inactive state and a second one for our active state. We define the value for our inactive state as 0, and for our graphic, we select Button Template Overview Off from the library here, which contains all the custom graphics that we imported in a previous lecture. Our second entry has the value 1, and we select Button Template Overview On for our active state. Now we do the same for the graphic lists of our three other template buttons. We start by copying the existing graphic list 3 times, and we rename them according to our main screen buttons. Now we dive into each graphic list and change the graphics accordingly. So step 1 is finished. We have created 4 graphic lists, 1 for each button. In our second step, we are going to create 4 local Boolean tags, which will be used to define which graphic to display for each button. These 4 tags are only going to be used locally in the HMI. They are not connected to any PLC tags. So under HMI tags in the tree structure, we start by creating a new tag group called Local Tags. And under this Local Tags group, we create a new tag table called Local Template Tags. Now we open the tag table and we create 4 Boolean tags here. I am starting my tag names with underscore here to indicate that these are local tags, and I'm using X in front of the tag names to indicate that these are Boolean tags. For integers, I would use underscore I. For reals, I would use underscore R, etc. The tag connections are by default set to internal tag, which means that these tags are local HMI tags. They are not synchronized to any PLC tags. In our third step, we're going to add 4 main screens to our application. 1 for process overview, 1 for alarms, 1 for recipe, and 1 for settings. Adding screens to an HMI application is done in the screens group here in the tree structure. One screen is already created here, so let's use this. We rename it to Overview and we open it. Under General Properties, we can choose to assign a template to the screen. Of course, we are going to use our template, so we enter the name of our template, which is Template. You can see now that our screen has received the template layout. So every time this screen will be active in runtime, all the features of our template will be available for the user. The next thing we need to do here is to assign a 0 or 1 value to our local Boolean tag, depending on if the screen has been loaded or cleared. We are going to assign the value 1 to our tag if the user enters the screen, and the value 0 if the user exits the screen. We implement this feature as follows. On the overview screen, instead of going to Properties, we are going to Events. Here you can add a function for when the screen is loaded or cleared. The function we are going to add here under Loaded is the setBit function, which we will use to set our Boolean tag to the value 1. So we press on Add Function and we start typing setBit. As you can see, TIA uses autocomplete, so it's very easy to find and assign functions. Alternatively, you can use this little downward arrow here on the right to get a list of all possible functions. Now we just need to assign our tag here, and done. So when the screen is loaded, this event will set the Boolean tag to the value 1. When we clear the screen, we need to write the value 0 to that same tag. So we go to the cleared event and we start typing reset bit. Now we just assign our tag here. And that's it for this screen. Now we copy this screen 3 times for our recipes, alarms, and settings screen. We start by renaming the screen names. Remember guys to use keyboard shortcuts as much as possible. They'll really save you a lot of time when building applications. Now we open our alarm screen and we adapt the loaded and cleared events with the state button alarm tag. Next up is our recipe screen. And finally, we make the necessary changes for our settings screen. Guys, our third step is finished. So far we have created 4 graphic lists and 4 local tags, and we added 4 main screens to the application. The final step of creating our screen navigation is adding 4 main screen buttons to our template. So let's start by opening our template again. We have allocated the area here on the right side of our screen layout for our screen navigation. Let's go and populate this area with our 4 main screen buttons. We start by deleting the placeholder, rectangle, and text. We won't be needing those anymore. The first button that we're going to add here is going to be our process overview button, which will allow the user to jump to the process overview screen. To add a button to the template, we open the toolbox on the right and we drag and drop the button element to the template. Let's assign layer 2, which is our graphics layer, to the button. And that's that. So this is a default button in TIA Portal. It doesn't look too bad, but I think we can do much better. Don't you agree? Let's make this button our own and implement custom graphics instead of the TIA default color transition and text. To change the graphic settings of our button, we go to General. Instead of using the default text, we are going to use a graphic list. As mentioned before, by using a graphic list, we'll be able to show a different graphic for the button depending on the state of a tag. We can assign a graphic list by selecting the graphic mode on the left here, and then selecting graphic list on the right. As you can see here, we need to assign a graphic list and a tag. As it happens to be, we have been very busy so far and we've already created these graphic lists and tags in our previous steps. So for the graphic list, we select our overview graphic list. And we select the corresponding tag. You can see that our button has taken over the 0 value or inactive graphic of our graphic list. Personally, I prefer not to use any text on buttons. If you visualize buttons with icons that are clear to the user, then you don't need to use any text with your buttons. This maybe doesn't make a lot of difference if you only have a couple buttons in your application, but if you have, for example, an HMI application with hundreds of buttons running on machines in a dozen different countries with a dozen different languages, it starts to make a big difference. Minimizing the amount of text used in your HMI applications means less translations needed, and furthermore, less text on your screens looks cleaner and visually more appealing. Now that the correct graphic list and tag are assigned, we need to change the appearance a bit. As you can see, our button is stretched and not in the correct size yet. Under Appearance, we set the border width to 0. And under Layout, we select No Stretching of Graphic, and more important, Fit Object to Content. Now the size of our button object has been adjusted to the size of our graphic bitmap. This only works, of course, if you create your custom graphics in the correct size, which I would really recommend that you do. The last thing we're going to change is the focus here under the Design tab. The focus of a button is a little rectangle that appears on the outline of a button when a user presses the button. We are not going to use focus for buttons in our application because, in my opinion, they look old-fashioned and our aim here is to make a modern-looking application. One small issue I have noticed in TIA Portal is that a focus rectangle will be shown in runtime even if you choose not to use the focus by setting the width to 0. To correct this small TIA issue, we are first going to set the color of our focus to our custom light gray color. Since our button graphic has the same custom light gray background color, we won't see the focus square when the button is pressed. Now we set the focus width to 0 and we are done here. Our process overview button is almost finished, but we're not there yet. Now that we've assigned a graphic list and a tag to the button, and we've taken care of the appearance of the button, we need to add a function that will allow the user to jump to the process overview screen when the button is pressed. To implement this function, we start by going to Events, and here you can see that we can add functions for different types of button interactions. We can add events for clicking, pressing, releasing, activating, deactivating, and changing the button. I've been using TIA Portal for over 10 years, and so far I've only used pressing and releasing events. Maybe you guys can think of scenarios to use the other button interactions. We are going to go with the default release event. Here we are going to add a function to activate a screen when we release the button, which basically means taking your finger away from the button after you've pressed it. We start typing activate screen and we assign the screen overview to it. Now when we release the button after pressing it, the process overview screen will be loaded. Our first button is now finished. We just need to position it correctly now, which is very easy since we are using the snap to grid feature. So we drag the button and drop it here at the top right corner of our screen. One button finished, 3 buttons to go. The process of adding these next 3 buttons will go much faster since we've already done all the groundwork with our first button here. For our next 3 buttons, we start by copy-pasting the existing button 3 times. Now we are going to position each of those buttons underneath each other, starting just below our first button. As part of the modern design of this application, I would like the buttons to touch each other without any visible gap between them. Because we are using the layout mode Snap to Grid, there is still a little gap here between the button and the button above it. By using the up arrow button on the keyboard, we can precisely move the button upwards and close the gap. Now we do the same for the other 2 buttons. Now that we have all of our buttons positioned correctly, let's adapt the graphic list, tag, and release event for each of our 3 new buttons. The button below our overview screen button will be our alarm screen button. So we change the graphic list, the tag, and we go to the events and activate the alarm screen under the release event. Our next button is the recipe screen button, so same process here. We change the graphic list, the tag, and the activate screen function of the release event. Finally, we have the setting screen button. We adapt the graphic list, the tag used together with the graphic list, and now we go to the events and adapt the function in the release event. That's it, guys. Time for a small celebration. We have successfully added screen navigation to our template. Before we conclude this lecture, let's quickly simulate the application and see if the screen navigation works. To simulate the application, we can either click on the icon right here in the toolbar, or we can just use the keyboard shortcut command Ctrl+Shift+X. Let's click on the icon, remember to select the device first, and see what happens. And there it is, our HMI application in all its glory. You can see our screen navigation right here, and by clicking on the different screen buttons, we navigate between the different screens. At the moment, all of our screens still look the same because we haven't added any screen-specific content yet. But don't despair, we are going to use this simulation quite a lot in the coming lectures, and with more screen-specific content added throughout the course, the simulation will start to look more and more like a real HMI application. I have my template already open here, and the information bar is situated right here at the top of our template. We're going to start by dividing the information bar into 4 sections: a user section, a screen name section, a recipe section, and a date and time section. We will start by removing the one large rectangle here and replacing it by 4 smaller rectangles, 1 rectangle for each of the 4 sections. The text here on the information bar might obstruct us while working on the rectangles, so I'm going to make that layer invisible. So we go to Layout and we make the text layer invisible. The height of each rectangle will be the same as the existing rectangle, but will have a different width for each of the 4 rectangles. For the rectangle for our user information, we define a width of 75 pixels and we place it all the way on the left. For our screen name rectangle, we start by copy-pasting the existing rectangle and we define a width of 239 pixels. Now we place it nicely next to our first rectangle. Copy-paste again for our recipe rectangle with a defined width of 132. For our last rectangle, which will display our date and time, we define a width of 234 pixels. Now we place it correctly on our layout, and we're done with rectangles for now. Let's show the text layer again and put some placeholder texts on top of the rectangles so we know which rectangle will be used for what in the future. So on the left will be our user information. Then we will have an area that will display the name of our active screen. Our third section will display the actual recipe number and name. And our last section will contain the current date and time. Now that we've assigned different sections to the layout of our information bar, it's time to get to the main topic of this lecture. We're going to add screen name information to the information bar. The desired result here is that the name of the active screen is displayed on the information bar. We're going to achieve this result by executing the following steps. First, we're going to create a text list with the different screen names. Then we are going to create a tag that we'll use together with the text list to define which text in the list should be shown. In our third step, we are going to set a different value for our tag depending on which screen is loaded. And finally, in our fourth step, we are going to add the text list to the template. So we start with our first step, creating a text list with the screen names. To create a new text list, we go to our tree structure on the left and we select Text and Graphic Lists. Under Text List, we create a new text list with the name Text List Screen Names. If our tag has the value 1, we will show the text Process Overview. For the value 5, we will show alarms. For value 10, we show recipes. And for value 20, we show settings. So why didn't I just use values 1, 2, 3, and 4? Why did I use the values 1, 5, 10, and 20? Well, the exact values that you use here are a matter of personal taste. But I like to treat each main screen, Process Overview, Alarms, Recipes, and Settings, as a screen category. So for example, the main alarm screen has the value 5. If I would like to add other alarm screens in the future, like an alarm buffer screen or an alarm diagnostic screen, I would like to use values 6, 7, 8, etc. for this. So by creating some distance between the values of the main screens, you allocate some space for more possible screen additions in the future. Now, I would like my screen names to include the screen value. The reason for this is that it will straight away be clear which screen has which value, and furthermore, it will automatically order the screens by number under the screen group. So for each screen name, I add the screen number to the front of the name. That's it for step 1. In step 2, we're going to create the tag that we'll use together with the text list. This tag will be a local tag and it will be part of the template tags. So we open the local template tags table. We are going to name our new tag screen number, the data type is integer, and for local tags, the connection is set to internal tag. In our third step, we are going to set the correct value for the tag depending on which screen is loaded. We start with our overview screen. Here we go to Events, and under the loaded event, we are going to add a new function that will assign a value to our tag. The function for setting a value to a tag is called setTag. The tag that we want to use is the tag that we've created in the previous step, and the value that we want to set our tag to for the overview screen is the value 1. Now we copy-paste this function to the loaded events of the other 3 screens and we adapt the tag values. So value 5 for the alarm screen, 10 for the recipe screen, and finally 20 for the settings screen. In our last step, we are going to add the text list with the screen names to our template. So we go back to our template. We are going to add screen names right here at the top, and let's start by removing this placeholder text here. Now, in order to visualize our text list on the screen, we are going to use an element from the toolbox called Symbolic I/O Field. So we open the toolbox here on the right and we drag and drop this element to our template. Because it's a text and it will be on top of our rectangle graphic, we start by assigning layer 3 to our element. Under General Properties, we are going to assign the text list that we've created in step 1 and the tag that we've created in step 2 to the element. So we select text list screen names for our text list and screen number for our tag. We are only going to output the screen names. There is no need for any input functionality, so we change the mode down here to output. Now what's left to do is to change the appearance a bit and place the element correctly on the rectangle. Under Appearance Properties, we select a transparent background with no border. Our text color will be our default dark blue color. Under Layout, we select Fit Object to Contents, and in the Text Format properties, we change the font size to 15 pixels and we change the horizontal alignment to centered. Now we place the element nicely in the middle of our rectangle here, and we are done with the final step. Let's quickly test what we've made in this lecture. You guys remember the shortcut for simulating the application? Ctrl-Shift-X, that's right. So as we navigate through the 4 main screens, notice how the screen name in the information bar changes depending on which screen is active. In this lecture, we are going to add the current date and time to the information bar. Furthermore, I will show you a quick and easy way to synchronize time between an HMI and a PLC. So we have our template open here, and we are going to add the date and time here on the top. We start by deleting this placeholder text here, and now we are going to add a date and time field, which can be found in the toolbox under Elements. Once again, we use drag and drop to add the element to our template. Under Miscellaneous Properties, we change the layer to layer 3, which is our text layer. And we have a visible date and time field on our template now. Now to change the looks a bit, we start by going to Appearance and we remove the background and the border. For our text color, we assign our custom dark blue color. Under Layout, the Fit object to content is marked already, this is good, and under Text format, we change the text size to 15 pixels and the horizontal alignment to centered. Now we place the element nicely on top of our rectangle, and we're done here. In the last part of this lecture, I'm going to show you a fast and easy way to set up a time synchronization between the PLC and the HMI. To set this up, we are going to look at the connection between the HMI and the PLC. In our tree structure, we double-click on Connection, which is situated right here under the HMI tags group. Under Connection, you can see that we have a connection called HMI Connection 1. This connection was created automatically when we've added our PLC tags to the HMI in the previous section of this course. For this connection, we can see that we have an HMI device with IP address 192.168.0.2 connected to a PLC device with IP address 192.168.0.1. What we're going to do now is to set up the HMI device as a time slave to the PLC. We do this by changing the HMI time synchronization mode right here. At the moment, it is set to none. In master mode, time synchronization is performed each time a connection is established. We are going to use the slave mode. In slave mode, time synchronization is performed each time a connection is established and then every 10 minutes. The first time synchronization is performed directly after starting runtime on the operator panel. Just one small detail here. Time synchronization is only performed while running runtime on the operator panel, so not when simulating the HMI application on your laptop. We still have two parts of the information bar that we need to work on: the recipe information and the user information. We are going to work on those two features of the information bar in later sections of the course, which will be sections specifically dedicated to recipe handling and user administration. So adding them later in the course fits better with the overall flow of building our application. So far we have added a screen navigation here on the right side of our template layout, and we've added two sections to the information bar here at the top of our layout. This lecture will be about adding a start and a stop button for our refill process to the template. We start by removing the rectangle and the text here. Since they were only placeholders, we won't need those anymore. Now let's add the start button. By copying a button here from the navigation area, we save time by not needing to set up the appearance and layout properties again. Furthermore, the copied button will have the correct layer, which is the graphics layer, assigned to it as well. Under General Properties, we are not going to use a graphic list. The reason is that we are not going to use a tag to indicate the graphic of our button. Instead, we are selecting Graphic here. And we are going to assign a graphic for when the button is not pressed and another graphic for when the button is pressed. So the graphic of the button will change when the user presses or releases the button, and this will give an intuitive feedback to the user when operating the button. So for the not pressed graphic, we select Button Template Start Off. And for the pressed graphic, we assign the graphic Button Template Start On. Now by going from graphic list to graphic, the button seems to have lost the layout property, fit the object to the content. So let's mark that again. Now we need to add an action to this button. The idea here is that when an operator presses this button, a PLC tag for starting the application is being held high or being energized. To add this action, we start by going to the Events tab. First, we're going to remove the release event here. Because this was copied over from the navigation button, we don't need this here. Now under the press event, we select the function setBit while key pressed. This function will keep the value of our start bit high as long as the operator presses the button. For our tag, we select DB machine state handler, command start. If you're interested in how this bit is used in the PLC application, go and check out the function block FB state handler under the program group machine and under the subgroup functions. This bit is basically used to transition the machine state handler from a ready state to a running state. Since we have added whole tag data structures in a previous lecture and have not mapped every individual tag, we now need to go down a list here using the 3 dots on the right and navigate the path to our start bit. Now we just need to position our button correctly on our layout. And that's it for the start button. For the stop button, we copy-paste the start button first, and we change the properties and event accordingly afterwards. So we change the tag on our press event to the db machine state handler command stop tag. And under general properties, we choose the correct stop button graphics for not pressed and pressed. Finally, we position the button nicely under the start button. If we now quickly simulate the application, we see that by pressing the start and stop buttons, the graphic changes. So there is an intuitive feedback, kind of like a handshake, to the user. Since we are not connected to a PLC, the event of the buttons, which is setting a PLC tag while the button is being pressed, cannot be tested yet. In a later section of this course, we will test all features of the HMI with a simulated PLC application. In this lecture, we are going to visualize the different machine states of our PLC application on the template. The idea behind this is that the HMI user, the operator, will have feedback on each screen for the actual machine state at any given moment. Of course, you could visualize the state of the machine on a specific screen, but then the operator would have to navigate to this specific screen each time he or she would like to check the machine state. By visualizing the state on the template, the user will get a feedback of the machine state on every screen. So let's get started. We have our template open here, and we are going to use the color, the appearance of our rectangle frame here to visualize the different machine states. So which states exactly do we want to visualize? We would like to visualize the different states of the state handler of our PLC application. So let's go to the PLC application quickly and check out which states we have. Our state handler function is situated under the functions subgroup of the program group machine. So we open the block and we scroll down to the last couple of networks where the different machine states are defined. Here you can see that we have a ready state, which is defined as state 0, a running state defined as state 1, a faulty state defined as state 2, and a reset state defined as state 3. So we have 4 states in total, 0 to 3, and for each state we are going to display a different frame color on the template. Now that we know which machine states we need to visualize, let's go back to our template. In order to change the appearance of the frame depending on the machine state, we start by selecting the rectangle frame and going to its properties. Now in the Animations tab here, you can see that we can set up an animation for the display of the object or for the movement of the object. We are going to add a color animation, so this is part of the display. So we open the display and we select Add New Animation. We are going to change the color, which is part of the appearance of the object, so we select Appearance. Here we need to assign the tag, which will define the appearance of the object. We want to display the state of the machine. So we select the PLC tag db machine state handler state state. As we saw before in our PLC application, the state handler of our application has 4 states, 0 to 3, so we're adding those states down here. The only thing left now is to change the border color depending on the state. State 0 is our ready state, so we choose our default light gray color for this. The running state we will visualize with a green border color. State 2, which is the fault state, is being visualized by a red border color. And to make it pop out even more than the other states, let's add flashing to it. When the faulty state is active, the frame will alternate between the background color, which is light gray, and the border color, which is red. For our final state 3, which is our reset state, we are choosing a blue border color. Now we have visualized the different states of our state handler on the template, and the state will be clearly visible on each screen.